Hi class, this is part 2 of section 4.4. Okay, in this example, we want to maximize the area enclosed by a fence. So a farmer with 2,000 yards of fencing wants to enclose a rectangular field plot that borders on a river. If the farmer does not fence the side along the river, what is the largest area that can be enclosed? Okay, so the river is up here, so this is the section that does not need the fencing. Okay, so fencing is going to have to deal with the perimeter around the rectangle. Okay, because the river borders on the top, we only need the fence down, I'll call this L for the length of the field, and then the width on the right and the left. So the perimeter is equal to L plus 2W in this problem. Okay, so I'll draw this in blue. Again, this is the river up here. So the fence is going to go along the two sides and then across the bottom opposite the river. Okay, so the perimeter of the fence is that 2,000 yards that the farmer has. And we want to maximize the area. So what is the largest area? Okay, so we need two equations. Just like in the last problem, with the one with revenue, we had the demand equation and then also the revenue equation. Okay, so these are similar. So the demand equation was linear. Okay, this perimeter is also a linear equation. The area is quadratic because we're going to be multiplying L and W together. Okay, so what we do is the perimeter, so we replace perimeter with 2,000. We're told how much fencing the farmer has. The perimeter in this problem is L plus 2W. Okay, again, we get that from the picture. So one length here on the bottom and the two widths on the side. Okay, and eventually the area is the equation we want to maximize. Okay, so let's go back to the perimeter equation. I'll solve it for L. So if I subtract 2W from both sides, I'll come up with the length. Okay, so now what we want to do is take this L, this length, and we'll plug it into the other equation. So area is equal to length times width. Well, L is 2,000 minus 2W. So that's our L value, and now we have our times W. So this is your length times width. We just replaced length with what it's equal to, 2,000 minus 2W. Okay, distribute. So we'll get 2,000 W minus 2W squared. And I'm going to write that the other way, just so the W squared is first. So negative 2W squared plus 2,000W is our area. Okay, so this is good because I can tell that this is going to be a parabola that opens down because I have that negative 2. The vertex is still negative b over 2a. So I'll have negative 2,000. 2 times negative 2 would give us 2,000 divided by 4, or 500. So the width should be 500, and this is being measured in yards. Okay, let's plug that into the equation here to get L. So 2,000 minus 2 times W, well, 2 times 500 is 1,000, and 2,000 minus 1,000 is 1,000. Okay, so the length is 1,000 yards, which again I got by plugging into this equation here that is solved for L. 2,000 minus 2W is equal to the length, and that works out to be L is 1,000. The question said, what is the largest area? So finally we need to multiply these two together. So then the largest area is 500 times 1,000. So we have 500,000 square yards. Okay, so I'm going to go through the problem again. So we have our perimeter formula. Okay, it's not the standard formula for the perimeter of a rectangle, and that's because we have a river bordering on one side. So that affects the equation that we need to use for the perimeter. Okay, solve it for L. So L is 2,000 minus 2W. Plug this in for the L in the other equation, in the area equation. Distribute the W, and I put the negative 2W squared first. It's not required, but just so you don't get the A and the B mixed up, right? So A is always the leading coefficient, B is in the middle, and in this case, RC is 0. Okay, so negative B over 2A to get the vertex, right? So in these problems, we will always have a parabola. So the maximum or the minimum is going to occur at the vertex. So since the parabola is opening down, this is our maximum. Negative B over 2A, negative 2,000 over 2 times negative 2 gave us the 500 yards. Plug it in to get the length. So the length is 1,000 yards. So again, I use this formula here now that I know W. Plug it in to get the corresponding length. And the question says, what is the largest area? So we want to multiply those two together. And so this is the largest area that can be enclosed by the fencing that the farmer has. Okay, example 4, this one you'll complete and turn in through Canvas. This time a farmer has 12,000 meters of fencing and he wants to enclose a rectangular field and then divide it into 2 plots with the fence parallel to one side. Okay, so the fencing this time goes the entire way around the rectangle, and he needs another side right in here. Okay, so think about what formula you need for the perimeter of this plot of land. Okay, what is the largest area that can be enclosed? Okay, so what I'm looking for is to develop a quadratic function like we did in the last example. Okay, so I'm not just looking at your final answer, but I want the steps leading up to it. Okay, good luck. Let me know if you have any questions.